This morning we're going to take a look at using the Waverunner 610ZI oscilloscope paired with the Picotest J2180A Preamplifier and a small near-field current probe to search EMI signals for embedded noise. We currently have our spectrum analyzer set up to measure a span of 1 MHz to 150 MHz, which covers all of the fundamental signals, at least, that we expect to see on this board, and probably many of the harmonics, at least for the lower frequency signals. So up front, we have an embedded sniffer probe, and depending on the board, some of these run approximately 25 megahertz and some run approximately 30 megahertz. We just kind of moved it around a little bit. But you can see it's a relatively strong signal, and we can see some of the harmonics as we get closer. And so it's just a nice little circuit to go sniffing EMI noise in. And since this is a relatively low Q circuit, it'll also be very responsive to power supply noise, and so we can move this around for phase noise and things like that. There's a point of load regulator in the back here, has a fundamental frequency of 2.8 megahertz, and so as we get close to the chip, we can actually see the 2.8 megahertz. You can also see there's an awful lot of high frequency content, up around 20 to 30 megahertz. We could probably make it a little bit easier to see if we turn the averaging on, which will give us a better noise floor. And there you go. Now you can see, we can see the response is much better. There's also a 125 megahertz signal, and it's a little bit uncertain where that one comes from because we do have a 125 megahertz oscillator here that you can see. And I do want to point out that in the 125 megahertz oscillator there's relatively little spurious response around it, primarily just 125 megahertz. Up front here we have a 10 megahertz precision oscillator, and that one has much wider band noise, and the reason for that is that we put a soft rising edge into this buffer, forcing very high shoot-through currents, and so we're able to see the EMI that comes from those shoot-through currents. Of course, we can use larger antennas, and a larger antenna won't give nearly the selectivity, but it will give much more sensitivity, and again, we can search all of the signals that exist on the board and their various strengths and spurious responses. Anyway, I hope you enjoyed our little demo. Thanks.